Hey, welcome back. Monte here, and hopefully you had a great Memorial Day weekend. We have now reached the first week of June, and we only have 3 weeks to go. 3 assignments. Easy peasy. So, happy June, and let's get started. Don't forget that we have a Teams channel, okay? And in our PreCalc Teams channel, we post all the videos, plus if you haven't been paying attention to some of the emails from school, here's all sorts of videos and links of stuff that's been happening like elections. We have a streams channel. You can watch the videos here. A lot of students are just heading straight to the internet. Spokane Public Schools, digital tools, Clever, Blackboard, and we'll look for our Honors PreCalculus. Okay, now don't forget, in the announcements, we have all the videos from the last 7 weeks, 3 weeks to go. Okay, now, for those of you in this class, I just mailed you the introduction to calculus. It was on the back side of that laminated sheet from PreCalc. Okay, we're trying to get ready for next year's calculus class. So there's an entire way of speaking when you talk about calculus. Limits, motions, infinity, as we approach, instantaneous velocity as opposed to average velocity. Okay, and your job over these last 3 weeks is to finish all the videos, okay? And limits in motion, you probably did it because there was only 3. Okay, no, 4. There was 4. Now, that was limit in motion. Now we're getting into limits in continuity, and there's only 2 videos. And then the last couple weeks we'll work on those derivatives. Let's get started. All right, so scroll down here. We did limits and motion the first week, okay, a couple weeks ago. Now we're into this idea of limits in motion as opposed to area. What the heck is that? Now you're not going to find these very difficult, okay? But it's an introduction to average velocity as opposed to instantaneous velocity. In other words, these curves and the area under the curve. Okay, so think of area of a triangle, but there's a little bit of a curve to it. Okay, so this first one is just a train travels 64 miles an hour in 5 hours. How far does he travel? That's kind of simple, isn't it? Yeah, right? If we're going 64 miles per hour for 5 hours, hours divided by hours goes away. We have nothing more than 64 times 5, which is 320 miles. Okay? Easy peasy. 320 miles. Done. Now, feel free to always go and watch every example. In this one, it's just view the example. And distance is rate times time. Okay? So think of this as a refresher on units, okay, as we get ready for the harder stuff. Okay, let's go to the next problem. All right, an airplane travels an average velocity of 64 miles per hour in 3 hours and 30 minutes. How far does the plane travel? (604 miles per hour times, now this is the little bit tricky here because we have 3 hours and 30 minutes. Okay, minutes, 30 minutes, that's half an hour. So in this case, it's just 3.5 hours. So 604 times 3.5, I shouldn't do that. 604 miles per hour times 3.5 hours. We're happy because hours divided by hours goes away, giving us 604, 604, 604, 3.5. 604 times 3.5, 2,114 miles. Okay? All right. So take your time, work yourself through these. 2114. Fantastico. And on each one, check for videos and help to understand them. Okay? All right, let's just do one more because I want you to do these on your own. Now here comes the idea. Estimate the area of the region, the x-axis under the graph from 0 to 5. Okay, so now, before we do that, think of the train problem, right? The train chugging out of the station, goes faster, 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 and then it slows down at the other station, right? So we're here, and we're here, and we had an average. Remember the average. Okay? We had the average velocity. Was that a train or a plane? Plane. 600, trains don't go 600 miles an hour. Okay, so that was average velocity. Average velocity over time. This right here represents distance. Okay? Serious. This is velocity. This is time. This is distance. The area under the curve is equal to the distance. Okay? So that's why we want you to take your time and grasp these concepts. Okay, so now that we know that, the area under the curve is distance. Whoa! We have this new curve, right? From here to here, it goes up to here, right? And it's from 0 to 5, okay? From 0 to 5. All right, now, estimate the area of the region under the curve. The area of the region, round to the nearest whole number. And you're like, well, I need the equation of the curve. Okay, so now, approximation method can be used. Approximation, rectangular approximation. So we create a bunch of rectangles and we add them all together. First partition the region into vertical strips and rectangles and determine the endpoints. Okay, so now we do this. Tick marks and approximate. The function at 10 is 0. Function at 9 is 6. Okay, so we're going to add them all up, aren't we? Okay, continue this pattern until we have a sum. Therefore, the area of the region from here to here is 56. So they added them all up. Okay, all right, so let's just do the same thing. So at 1, there we go. F of 1. You see how we could go up to 4 right there? Okay, so we have 1 times 4. So this is 4 boxes. But do you see how it's only going to be like half of that? So I'm going to put a 2 here because it almost looks like it goes diagonal. Okay, F of 2. So at 2, we're going to go up 6. 6 times 1. 6 times 1 equals 6. This is my question mark here. Are we going to use a 4 or a 2? I'm not sure what they're going to do there. So then, F of 3. So we're approximating the area under the curve. 6 times 1. Okay. Yeah, I didn't do that very well. 1, 2, not drawn to scale. 3. So the 3 is going to be 6 times 1. And this was 6 times 1. Let's go, let's do this as pink. Okay, so 6 times 1, so we got another 6. Now we're going to come down the other side. It's symmetrical. 4 is going to be the half again. So we're going to have a 4 question mark, or should we do the 2, right? Yeah. From 4 to 5. Oh, f of 4. 2 is 6, 6, 6. This is the 6. Okay, sorry, 6. So we have region f of 1, f of 2, f of 3 is the big middle, f of 4, and then f of 5, it comes down the other side. Okay, so in this one could be this triangle, right? Okay, so now f of 5 is going to be 4 or the 2. Okay, so I think they're going to want us to have 4. They're going to want us to do this. 6, 6, 6. 6, 6, 6, 18 plus 8. I think they want 26. I'm going to assume, if we don't get that right, because we could see this was a half, I wonder if 18, 22 is a better answer. Okay, so whole number. So I'm going to do the 26 first. Okay, rectangles, vertical strips, the height of it. Okay, I'm going to assume the 22 is a better answer. Correct answer is 21. So how'd they get 21? 1. So we approximated. Okay. So they approximated. They probably went right there. 1 times 3 to get 21. 21. Okay, so let's, yeah, we got a minute here. Let's do this. Actually, you know what? I can cheat here, can't I? Okay, now let's do a better job here. Okay, we know this one's real nice. Okay, so this is going to be 1 times 1, 2, 3, 4, 5, 6. 1 times 6. So we have 6 units. We love this. I wonder if they went like this and like this. 5 times 1, so they got a 5 and a 5. And then I wonder, .5 times 1, 2.5, 2.5. Let's see what that adds up to. This is what they did. So you see how by doing it this way, this piece fills that. This piece fills that. That piece fills that. That piece fills that. Okay, so what do we have here? 5 plus 6 plus 5. That's 16 units. Yep. 2.5 plus 2.5. 16 plus 5 is 21. Okay, So I was too broad. They wanted us to break it down even more. So break it down even more. Cool. So hopefully that was helpful. Okay? We're not in a hurry. It's a way of talking. Okay? All right. Wow. 1 through 7. You see how this is going to take more time? Okay, so next week we'll attack this one. Have a great week. Happy June.